Alright, so let's begin. Who was the last question? Nobody knows. Okay, start the question, Buddha. Right, what might be the answer? How to calculate it? Remember, we need to make use of here some law which is called as Wayne's law. So, according to this law, wavelength into temperature is equal to constant, which means more the wavelength, less the temperature, less the wavelength. Louder. More the temperature. Sure. Guarantee. ಯಾಕೆ ಮೊದಲೇ ಸತಿ ಲೆಸ್ ಅಂತ ಹೇಳಿ ಕೇಳ್ತಪ್ಪ ನನಗೆ ಲೆಸ್ ಅಂತ ಹೇಳಿದೆ ಅಥವಾ ನಂಗೆ ಕೇಳಿತ್ತ ನಂಗೆ ಕೇಳಿತ್ತು ಓಕೆ 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 ಸೊ now let's come back for our question. ಇಲ್ಲಿ ಏನು ಕೊಡ್ತಾನೆ there he has given two wavelengths and he is asking us to find out ratio of the surface temperature. That means we can say that lambda m1 T1 is equal to lambda m2 T2. Now as we have to find out the ratio of the temperature, we can say T1 by T2 is equal to lambda m2 divided by lambda m1. So what is lambda m2? Lambda 2. Second wavelength, 480 nanometer. Since both are in nanometers, we can substitute it as 480 only. Divided by, what is lambda 1? 360. So we can say 12 times 3, 12 times 4. That means T1 by T2 is equal to 4 by 3. So the right option is option 3. Sure of it? 100%, 200%, 500%, confident. Lock किया जाए? Might be option. Back you have to check it out. Okay. You have to check out at the back or you have to check out at the back of the book for the answer key that is given for question number, which is that? 9, for thermal properties of matter that we are discussing today, which is given in the crash course material of Vividya Academy Mangalore for the crash course batch of CET 2025. Guarantee? So option 3 is the right option. Very good. Then which is the left option? Other options are left options. Okay, okay. ಅರ್ಥ ಆಯ್ತಾ? Sure of it? ಬರ್ಕೊಂಬಿಡಿ ಮೊದಲು. ಆಮೇಲೆ ವಿಲ್ ಗೋ ಫಾರ್ ದ ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶನ್ itself. Okay? Finished? Finished or finish taking it down? Finish taking it down. Or finished taking it down, whatever is written on the smart board by making use of the smart pen in colored white against the black background in your book, ruled notebook of 200 pages, of ballpoint, blue or black pen? Blue pen. Oh God, so much big sentence you have to say, huh? Isn't it? Okay, forget about that. Let's go for the next question now. Okay, it's a theory question, Mutta, so you can answer it. The answer is first decreases, then increases. Okay, it's just a theory question for it. So leave that, go for the next question. हाँ बेटा. Okay. Oh, I thought it is volume. How? Read the question. 10th one. Okay. So it is 4 degrees Celsius. I also got another similar type of the question in other class. So I had mixed up with that. Huh. But of course, verify the answer. I may be wrong. I don't think so. Always. But still, I may be wrong. Correct. Yes. 1 gram of ice. Yes. So the first thing that you have to understand here, children, is that when you go for the temperature of the mixture, you need to first understand what is the substance present inside the mixture. Now the substance present inside the mixture may be ice, liquid water, or steam even. Okay, or it might contain ice and water, it may contain water and steam. So in that condition, we have to identify what is present in that mixture at the beginning. Okay, so to do that, let us try to analyze what is the heat supplied to ice when it melts. So remember, when ice melts, there is no change in temperature, because ice will be making its conversion to liquid water, and because of that, whatever energy or heat energy is given to it, it's only to break the bonds between the molecules of ice so that it gets converted to water. Okay, and that heat is called as latent heat. Okay, now here we can say Q of ice is equal to mass of ice into LF, and this LF is called as latent heat of fusion. What is it LF called as, Buddha? Yes. So this heat does not result in change of temperature. So that means if you are going to keep the thermometer on ice and trying to find its temperature at any amount of heat given to it, it will always be 0 degree Celsius. Okay, so now we can see this is equal to mass of ice is 1 gram, I will take it as 1 only, and LF in terms of CGS unit is given as 80. Okay, so this is heat supplied to ice. Now let us say after getting converted to water, okay, what will happen? The temperature of water will be increased, and the increase will occur until 100 degrees Celsius. At 100 degrees Celsius, all of water will get converted to steam. So therefore, water heat, or we can say QW, is equal to M water into specific heat of water into change in temperature. Now mass of water is nothing but mass of ice itself. So it is 1 into specific heat of water is always 1. If it is, we can say CGS unit. If it is SI unit, it will be 4186. Okay, SI unit it is 4186, but in the case of, we can say CGS unit, it is always 1 into delta T. Now what is the change in temperature? As I told you, the maximum temperature that the liquid water can reach is 100 degrees Celsius. The minimum temperature is definitely 0. So that is equal to, we can say 100. So now let us go for Q ice and Q water and take the combined temperature. I will call it as QIW. So QIW is equal to Q water plus Q ice, and it is nothing but, we can say 80 plus 100, that is equal to 180. Okay, this is in terms of, we can say CGS unit. Now let us say we are going to find out what is the heat supplied or heat absorbed or heat given out, whatever the case is, by steam, right? And that is given by Q steam equal to mass of steam into LV. What is that LV called as? It is called as latent heat of vaporization. Okay. So now Q steam is equal to, the mass is how much here? 1 gram, and latent heat of vaporization is 540 CGS unit. That means Q steam is equal to 540 CGS units. Now compare this with this Buddha. Here I can see that the complete heat ejected by ice and water when it is converted to steam is how much here? 180. And what is the heat ejected by the steam? It is 540. That means 540 is greater than 180. Correct? What does that mean? It means that this mixture will also be converted to steam itself. Getting it? The whole mixture of ice and water will be converted to steam itself. And what is the temperature of the steam? Louder. 100 degrees Celsius. So the right option is option 1. Verified? I may be wrong. Correct? Sure of it? 100%, 200%, 500%, confident, lock kiya jaye. Very good. Take it down. And of course, the other questions you can give it a try, because it is questions on Newton's laws of motion and we can say some theory questions. Okay. So just give it a try, and if you don't get it, no problems. I will solve it in the next class. Now let's go for thermodynamics after this. Okay. Alright, Buddha? Sure of it? 100%, 200%, 500%, lock किया जाए. Very good. Finished? Or finished taking it down? Sure. Or finished taking whatever is written on the smart board with black background, making use of smart pen with white ink on your ruled or unruled book of 200 pages with ballpoint, which pen? Blue or black pen? Blue pen. What here? Again it comes. What to do now? Now read the question properly. Which question? Thermodynamics, first question. Very good. I don't need this. What happened? That is off. This only it is? No. Then where is the remote? Who is having it? On it. Yeah, read the question. Which question? First one question. Very good. Why first one question? You can read first question. And read it properly. Okay? No mistakes. T2 by T2 minus 5. So T2 by T2 minus 5, how can you substitute here for T2? What to do now? What did I say at the beginning? Be careful while reading the question, but be more careful while reading the options. Very bad. So write that option tomorrow 10 times and show it to me. Okay? How many times, sir? Now read it properly. Option 3. Option 4, T1 plus 10, T2 minus 10. Very good. So, what is the meaning of efficiency? Efficiency is nothing but the ratio of useful work done to the amount of heat given to it. Okay? But when we can say the Carnot heat engine comes in, that time efficiency is equal to 1 minus temperature of the sink divided by temperature of the source. Okay. So remember, normally temperature of the sink will be substituted as T2. Temperature of the source will be substituted as T1. Okay. This is what you need to remember here. So eta is equal to 1 minus T2 divided by T1. Okay, very good. Now, when you come for our question, there are two cases. First case is the one when T1 equal to T1, T2 equal to T2. No complications, direct substitution. Okay, here we can say eta is equal to, or T sink, sorry, is T1, sorry, not T sink, T source. And T sink is T2. Okay. From where did this Tridev came here? From where did this Tridev children came now? Food. Where? Hostel. Food and come back. Okay, okay. At least you could have brought me also here. What are you doing? Very bad. Now, let's come back for this. In the previous particular time, I had seen one child eating ice cream without offering it to me. Very bad. And now we can say our children have had the lunch without offering it to me. Very bad. Okay. Now pay attention. Whereas I always offer, we can say tea, coffee, green tea, lemon tea, masala tea, what dear? Okay. Don't look at me like that here. I always offer, isn't it? Tomorrow. Very good. Okay. So, what is eta now? Eta is 0.5. Correct? Sure of it? 100%, 200%, 500%, confident? Lock ke jaye? Very good. Now, let's come back for formula. Eta is equal to 0.5. Okay. Equal to 1 minus T2 by T1. Clear? Very good. Okay, bacha buddy. Pay attention, children, now. So it is 1 minus 0.5. That means we can write T2 by T1 is equal to 0.5, which means T2 is equal to 0.5 T1. Correct? Yes. Now let us go for the second case. What does the second case say? T source equal to T1 prime. Okay, because here the temperature has changed. T sink equal to T2 prime. But eta remains same. What is eta? 0.5. See the question here. What are you doing, Buddha? I told you that you should remember the question now. What to do now? Write the question tomorrow. One time and show it to me. Okay, how it answer? So, second eta is also 0.5 only. So, here. Now, let's go for the same formula. Eta is equal to 1 minus T sink divided by T source. So, that is nothing but we can say 0.5 is equal to 1 minus T2 prime divided by T1 prime. Following the same method, I can write T2 prime divided by T1 prime is equal to 0.5. Okay, what does that mean? That means that T2 prime is equal to 0.5 into T1 prime. Now here, unfortunately, we don't have any particular, we can say, method to identify what is T2 and T1. We only can say that T2 prime is equal to 0.5 into T1 prime. But what actually is T2 prime in terms of T2 and what actually is T1 prime in terms of T1, we don't know that. Are you getting it? So, what we can do here is that when we divide this, we can see that T2 prime divided by T2 is equal to T1 prime divided by T1, which means that this T2 and T1 prime should both have same type of T2 and T1 values. But unfortunately, we can't say which particular values it is. It might be option 1, option 2 is different, option 3 and option 4 also might be different, right? But we can't say. So what we'll do now? We'll do the next best possible approach. We will take the last equation and we will find out for which option we get LHS is equal to RHS. Okay. What we'll take? We'll take all the options, we'll substitute all the option value so that we are going to get LHS is equal to RHS. So let's take option 1. Okay, Buddha. In option 1, let me take this equation. this equation is T2 prime is equal to 0.5 into T1 prime. All right. And here, what is T1 prime? T1 prime is, see this thing, Buddha, what is T1 prime? The first option, 2T1. So that means T2 prime is, sorry, we'll go for RHS. RHS is 0.5 T1 prime, it is equal to 0.5 into 2T1. So what is 0.5 into 2? It is 1. That means 0.5 T1 prime is equal to T1. Therefore, RHS, because of option 1, is T1. Correct? Now let us go for LHS. So in LHS, we get T2 prime. Correct? Now what is T2 prime equal to Buddha? So T2 prime is equal to 2T2. Okay. Now what is this T2 in terms of T1 from this equation? Correct, loudly. 0.5 T1. Now what is 2 into 0.5? It is 1. That means T2 prime is also equal to T1. Correct? So is LHS equal to RHS? Yes. That means option 1 may be the correct option. Verified. Correct. Very good. Shabash. Right. So see the diagram, Buddha. So what happens in the diagram? We can see that diagram indicates us that it is an isothermal process. That means temperature is maintained constant. So in that condition, internal energy will be constant, because the changes in internal energy will occur if and only if temperature is changed. But if temperature is maintained same, there is no change in the internal energy. So the right option is fourth option. Okay. Okay, so again, what you have to do? Go for option 1, option 2, option 3, option 4, and find out for which value of those options we get eta equal to 1 minus T2 by T1 maximum. Okay, so T2 is the temperature which is lower, T1 is the temperature which is higher. Okay, so find out that is trial and error method. You can do it yourself. Okay, beta, go for the next question now. Now, right. Now remember, he is telling us efficiency is 70%. Now what do you mean by 70%? It is 70 divided by 100. Since it is 70 divided by 100, that will be 0.7. Okay, beta. So 0.7 is equal to 1 minus T2 is given. What is the value of T2? 27 degree Celsius. That we have to convert it in terms of Kelvin. So it is 27 plus 273. Okay. Divided by, we can say, the temperature of the source, that is T1. Now take this term to the left hand side, take this term to the right hand side. Therefore, we can write 27 plus 273, that gives me 300 divided by T1 is equal to 1 minus 0.7. So what is 1 minus 0.7? It is 0.3. So therefore, 300 by T1 is equal to 0.3. So that implies T1 is equal to 300 divided by 0.3, that is equal to 1000 Kelvin. But we need to convert that in terms of degree Celsius. So what we will do? We have to subtract 1000 by 273. The final answer that you are going to get will be 727 degree Celsius. So the right option is option 3. Verified. I may be wrong. Yeah, but I am looking at you. Okay, so this type of the solemn process is called as adiabatic. Okay, so leave that question, go for the next. Yes. What might be the answer, Buddha? So direct formula. Same thing we have to substitute. So instead of eta, We have been given what is T2 and T1. So eta is equal to 1 minus T2 by T1. So that is equal to, we can say 1 minus T2 is how much here? No, that is, as I told you, lower value put. Lower value means it should be 300 divided by 500. So that is equal to 1 minus 3 by 5. That means eta is equal to 2 by 5. 2 by 5 is nothing but we can say 0.4, and 0.4 means 40%. Option 2. Verified. Correct? So, of course, eta is equal to 1 minus T2 by T1. Correct? What is it equal to? 1 minus. What is T2 beta? 300. What is T1? 400. Now what is 300 by 400? It is nothing but we can say 3 by 4. So what is 1 minus 3 by 4? It is 1 by 4. So that is eta. Alright. Now eta is also equal to, we already done this here, useful work done divided by heat supplied. That means we can say that it is W divided by Q. That means 1 by 4 is equal to useful work done. How much useful work done given by? 800 joule divided by, we can say, Q. Now that means the final answer will be Q equal to 800 into 4, that is equal to 3200 joule. So what is the right option now? Option number 2. Verified. I may be wrong. Correct? Very good. Yeah, but I'm looking at you, right?
The SI unit of specific heat capacity is joule kg inverse Kelvin inverse.
1 minute. The option that I heard was Joule K, kg inverse, Kelvin inverse. Sure. Is that the option? Joule K, kg inverse, Kelvin inverse. What here? Again, my students can completely confuse me now. Tell me properly option 1.
Joule per kg per Kelvin.
Ah,
Option 2 joule per mole per Kelvin.
Ah.
Option 3 joule per kg. Option 4 joule per Kelvin.
okay. The question is theory question. Option is option 1. Verified. Don't just take it down. I may be wrong. Correct. Very good.
For which combination of working temperatures the efficiency of Carnot
Okay, this you can do it yourself, Buddha. The same question as question number 2, isn't it? Same type. Substitute we can say T2, T1 and calculate the answer. Leave that. Go for the next.
750 Kelvin, option 4 1000 Kelvin.
Again we have to use, we can see which option, which question, which formula now, eta equal to 1 minus T2 by T1, and then go for the calculation of that, find out the, we can say, relation between energy and eta, and then go for, we can see, the value. Same thing as we have done here. Okay, similar type. Now next, now do you
thermodynamic system undergoes a cyclic process. A, B, C are shown in the diagram. The work done by the system per cycle is option 1 minus 750 joule, 2 is 750 joule, option 3 1050 joule, option 4 minus 1 250 joule.
1 minute. Okay, let's see that question later on. Yeah, can you read the question again, Buddha?
The thermodynamic system undergoes a cyclic process. A, B, C are shown in the diagram. The work done by the system per cycle is
Options.
option 1 minus 750 joule, option 2 750 joule, option 3 1250 joule, option 4 minus 1050.
Okay. So let us say this is the diagram. Correct? Is it like this? Sure of it. Good. Where is A? On the top. Where is B? Down of A. Where is C? Side of B. Correct? Now, how is the gas taken from A to B? Is it from A to B or B to A? A to B. That means it is like this. Correct? Next we can see it is from B to C. And last it is from C to A. Correct? Yes. Now I think we get some values here. What is the value given here? 5. What is the value given here? 10. What about this? 100. What about this? 400. Correct? Now see, the work done in the process is such that the volume decreases and the pressure increases. If we take this. Now as the process is cyclic, the work done in taking the gas from here to here is the same work done that is done when we take the gas from here to here and here to here. So therefore, we can say work done is equal to scalar product of force and displacement. So that will be F dx cos theta. Theta is equal to 0 degree. So therefore, cos 0 degree is, what is cos 0 degree? 1. Sure. 100%. 200%. 500%. Confident. Log किया जाए. Okay. So, what? Somebody called me? Yeah, but what happened? Okay. Now, F dx is the work done. Okay. But what is F? It is pressure into area. Into we can say dx. Now, what is the dx? It is a change in volume. So, we can take it as P into dV. Now, when you go for the graph, remember that product indicates area, division indicates slope. So that means we should take the work done, it is equal to area of the triangle, that is nothing but half into base into height. So half will remain as it is, we are not going to change it. What is base? Base is nothing but this. So So that is nothing but we can say 10 minus 5. Okay. Into height is nothing but we can say this. Now here we can say, before getting into the next part, so here we can say unfortunately this becomes 5 minus 10 children, because the volume decreases, into, of course, 400 minus 100, so that is equal to we can say half into minus 5 into 300. So 2 times 1, 2 times 150, so that means the work done is equal to minus 750 joule. So the right option is option 1. Verified? Done? Finish taking it down? Finished? Then finish it. Aram se, no problem. Yes. What might be the answer now? What might be the answer? See the question again. What does the question say? It is saying that the process is taking place at constant pressure, which means that volume and temperature changes. And in that condition, we know that the law says volume is directly proportional to temperature. Now, as we can say volume is doubled, temperature is doubled. That means we can say T prime is equal to 2 times T. What is the temperature? 27 degrees Celsius. Convert that in terms of Kelvin, that will be 273. So it is 600 Kelvin. Now go for the heat supplied. The heat supplied is given by number of moles into specific heat at constant pressure into the change in temperature. So what is the number of moles there? 1 mole into the specific heat at constant pressure is given by 7 by 2 R. Now how do we obtain that? This is obtained because the considered gaseous substance is O2, which is a diatomic gas. And since it is a diatomic gas, specific heat at constant pressure is 7 by 2 R into the change in temperature, that is nothing but we can say 600 Kelvin minus 300 Kelvin. So that is equal to 7 by 2 R into 300. So that is nothing but we can say 1050 R. So what is the right option now? Option 3. Verify it. Finished? Good.
A certain amount of heat energy is supplied to a monatomic ideal gas which expands at constant pressure. What fraction of the heat energy is converted? Option 1, 2 by 5. Option 2, 5 by 7. Option 3, 1, 4, 2 by 2.
Option 3, 1, 4.
Option 3 is 1. Option 4, 2 by 2.
Option 4. Okay. What? What happened now? Who called me?
You can't say because
Pay attention now. So what is we have to find out? Fraction of heat energy. That means we can say fraction of heat energy will be work done divided by heat energy given. Now remember first law of thermodynamics, the total energy absorbed or given to any gaseous substance for that matter is utilized in two parts. One is doing the external work and the second is for change in internal energy. Now here this Q can be taken as M into Cp into delta T, or else we can take that as mu Cp into delta T. If it is we can say moles, then we can take it as mu. If it is we can say mass, we can take it as M. So therefore we can say it is mu Cp into delta T. That is equal to, work done will be W only, but what is U? That is mu Cv into delta T. Now what is the work done? The work done is mu Cp delta T minus mu CV delta t. Can I take anything common in this? Mu delta t can be taken common. Okay. In the bracket, Cp minus Cv. So this is the work done. But since we are finding out the fraction of work done, we can take that is nothing but W by Q. So what is W now? Mu delta T in the bracket Cp minus Cv bracket close divided by Q is this mu Cp into delta T. Now what can we cancel off? Mu delta T can be cancelled off. Therefore, W by Q is equal to Cp minus Cv divided by Cp. Now expand this. We are going to get W is equal to Cp by Cp, sorry, W by Q is equal to Cp by Cp minus Cv by Cp. So W by Q will remain as it is. Cp by Cp is 1. Cv by Cp we can write it as 1 divided by Cp by Cv. So remember, for a monoatomic gas, the gas that is been given there, we have Cp equal to 5 R by 2 and Cv is equal to 3 R by 2. Substitute that in this equation, we can write W by Q equal to 1 minus 1 divided by 5 by 3. Correct? Because we are dividing Cp by Cv, 5 R by 2 divided by 3 R by 2. So R by 2 R by 2 will cancel, so we are going to get 5 by 3. Therefore, W by Q is equal to 1 minus 3 by 5. And the final expression that you are going to get will be W by Q equal to 2 by 5. So what is the right option now? Option 1. Verified. So do one thing, you can try question number 11, question number 14, 15, 16 yourself. Okay. If you have any doubts in that, you can let me know. We'll discuss it. Now I can go for 17th question. 1 minute. I think some people should write that. Let the children write it, then we can go for the discussion of that. Good. Finished? Good. Sit straight, Buddha. Properly. Got it? Read the question now. Right. What might be the answer? Remember, he is asking us the area. Correct? Now, we can see the graph and say that the curve in the graph might be a rough rectangle. Okay, beta? It might be a rough rectangle. That means we can say that area is equal to area of the rectangle. What is the area of the rectangle? Length into breadth. Okay, so it is L into B. Alright, now what is that L into B, Buddha? L into B is 6.25 minus 2.5. We can select two positions. Okay, now we can say, unfortunately for these two positions, the breadth becomes difficult to determine. So we can say that this 6.25 may lie somewhere around 1600. Okay, now determining 2.5 becomes difficult, so we'll take the nearest value, that is 800. Okay, Buddha. Now that is equal to, what is 6.25 minus 2.5? 1.75 or 3.75, Buddha? Verified? I think it might be 3.75. Right? 1600 into 800, that gives me 800. That means we can write it as 375 into 8. What is 375 into 8? I think the answer is 3000. The right option must be option 1, verified. Done. Very good. Take it down. Simple question, but problem is we can say it's not been given in a proper manner. Lines we can see it does not coincide with the actual values. So we can say rough values there. Are you getting that? So that problem is there in CET. You will be having, we can say, some rough arrangement of values. Finished? Or finished taking it down? Finished? Hey Bhagwan, what did you finish? Whom did you finish? When did you finish? Why did you finish? Why do my children always confuse me only here? Last question. Yaru tirappa? One mole of one mole. This is question. 1 mole of 1 mole. 1 mole of 1 mole ಅಂದ್ರೆ ಬಿಡಿಗೆತ್ತಾ? ಓ 1 mole ಅನ್ನ ಕಟ್ ಮಾಡಿ ಇನ್ನೊಂದು 1 mole ಹಾಕಬೇಕಲ್ಲ ನೀವು? ಓಕೆ. Right. So, simple question ಕೇಳಿದವಲ್ಲಿ work done is equal to, remember, P into dV or delta V. Now what is the pressure? The pressure which remains constant in that graph is P naught. Correct? Now the volume that changes will have the maximum value of 3 V naught and the minimum value of V naught. That means the work done, children, is equal to P naught into 2 V naught. That means the work done is equal to 2 P naught V naught. So the right option is 444. Very good. So we can say 444th option. Okay. So option is 444, which means, hey, I heard like we can say the 3 balls hit, we can say by 3 force. 444. Okay. So 444 is the right option. So see whether it is correct or wrong. Very good. Shabash beta. So I think all of you understood this. Very good beta. Okay, still we are having 20 minutes. Last two question they will do it. Okay. Start beta. Go for I think we had left 14 question, isn't it? 14th बेटा. हाँ 14वां क्वेश्चन पढ़ो बेटे यहाँ पे 14वां क्वेश्चन. ठीक है. So what happens? Yes, first decreases and then increases. I think this is the question that I heard maybe in the previous class. Next, 15th question.
A number of Carnot engines are operated at identical coal reservoir temperatures. However, their hot reservoir temperatures are kept different. A graph of the efficiency of the engines versus hot reservoir temperature is plotted. The correct graphical representation is.
So of course we can't read the graph. So we can take option 2 as the right option. Okay. Verified, I may be wrong. Verified, I may be wrong. Okay. Yeah, but the last question. Okay, third it is second law of thermodynamics. Okay.
Sir, 14th one. That side is third option.
What is the question, Buddha?
In adiabatic expansion of an ideal gas, the product of pressure and volume
The product of pressure and volume. Okay, options are?
remains constant, at first increases, then decreases, increases.
Okay. So, remember the product of pressure and volume, when you go for it, adiabatic is nothing but we can say sudden change that takes place in volume or pressure due to, we can say, a sudden exchange of energy. Now, when that happens, then the product of pressure and volume. So, PV to the power gamma is equal to constant. Okay. So, now remember, as pressure increases, volume decreases and vice versa. So, yeah, but it is decrease. It's right. Right. Any other questions there? No. Okay. Okay, let us have a game. All right. Good. So, I will write some list of numbers here. Okay. There are, we can say, 6 list of numbers here. Sorry, 5 list of numbers here. So who will help me out now? Yeah, who is Anas? Yeah, Buddha. Help me out. Okay. So take any number from 1 to 31. Until 1 to 31. In between, including 1 and 31. Okay. Don't say it to anybody else. Say it to your friend. Anyone. No problem, but still we can say you need to cross verify it. So, okay. Now, is that number there in the first list? No. Is it there in the second list? Yes. Is it there in the third list? No. Is it there in the fourth list? No. Is it there in the fifth list? Yes. Okay. So, who will help me out here? Yabuda, will you help me out? Huh? Okay. So, take the first number in this list. What is the first number? 2. What is the first number here? Add them. 18 is the number. Really? Or just you did one? Okay, let's see whether it is, we can say what? Real one or what we can think it is. Okay. Yeah, Buddha. Can you remember any number? You only. Don't say it loudly, yaar. Another number. Okay. Say it to your friend. Is that number so funny? Okay. Is it there in this list? Is it there in this list? Is it there in this list? No. Is it there in this list? Yes. Is it there in this list? No. All right. Who will help me out? Yeah, Buddha? Will you help me out? Okay. So take the first number in this list. What is that? 1. First number in this list. 2. Add them both. 3. Take the first number in this list. 8. Add them. 11. Correct? Very good. Who is Saad now? Yeah, Buddha. Okay. So remember any number from 1 to 31. Okay. Huh. So now say to your friend with that number is. Okay. Is that number there in this list? Yes. In this list? Okay. So is that number there in the first list? No. Second list? Yeah. Third list? No. Fourth list? Yeah. Fifth list? Yes. So who will help me out? Yabda? You only here, but ಯಾರಾದ್ರೂ ಹಿಂದೆ ಅಲ್ಲಿ ಹಾಂ ಸೊ ಗೋ ಫಾರ್ ದ ಫಸ್ಟ್ ನಂಬರ್ ಹಿಯರ್ ಯಾವುದು 2 ಗೋ ಫಾರ್ ದ ಫಸ್ಟ್ ನಂಬರ್ ಹಿಯರ್ 8 plus 2 10 go for the first number here 26 should be the number sure very good correct or wrong 25 so with 25 यहाँ पे है यार come on children okay so anyway I think this is clear to all of you. Okay, 10 minutes remaining. We can do one thing. You can do your work, and if there is any doubt, you can let me know. I will discuss the doubts here. Okay? Take the book and start reading. Okay? Don't waste your time. There are, but simply it requires a bit time. So, yeah.